my lab report for lab 2. So an introduction to this lab, the objectives are to revisit the charge shapes from lab 1 from a different point of view, treating the tape as it has distributed charge versus 2-point charges. And it's the same experimental data, but it's explained by different physics, and this leads to a different total charge on the tape. And still, the goal is to determine the excess charge and number of electrons lost or gained. And I found that, like lab 1, the tape has a positive charge with a deficiency of electrons, but the charge of the tape is closer to 2.64 times 10 to the negative 8th coulombs rather than around, I think, 2.06 times to the power of negative 8 compared to last time. Key physics is also Newton's second law, which leads to force balance, as well as distributed charges, which is a new topic. In this lab, it's linear uniform distribution, and this formula right here is derived from the ratio of total charge over the total length related to the infinitesimal portion of charge, which is dq over dl. And Coulomb's law also has a play where the force on a point charge is the external electric field acting on it times the magnitude of that charge and sign. So in this lab, the source is tape 1, which is the tape that's moving closer to tape 2, and the observation location is the location of tape 2. And yeah, the force on the observation charge is the magnitude of that charge times the electric field from the distributed charge. So the procedure, like last time, it was 2 charge pieces of tape, where x is much greater than r, and r is the minimum distance for the 2 tapes to interact. They reached 22 centimeters long, and they were charged by this procedure, and tape 1 was brought near tape 2 until an interaction was observed, and the distance where they interacted was recorded. And the findings for this was that the charge tape was attracted to a pin, known to be negatively charged, so it was positive. And also, the charge tape was polarized by my hand, drawing electrons in my skin near it, leading to attraction, which explains why it was attracted to my hand. And it was both tapes have the same charge, which is why they repelled each other. And then the experimental data, the force of gravity on the tape was found to be 0.003105 newtons. And using the equations from slide 3, which are these over here, which are found in the formula sheet, substituting variables and solving for Q gives this expression for Q, which I could then find to be this value. So the computational model, this is the key lines of code in my model. So this section of code is where we start to see the distribution of charges. This is the magnitude of each point charge, where capital Q is the total charge. This is the mass of each point charge. Capital M is the mass of the tape, and N is the number of point charges, and dq is the infinitesimal amount of charge we're looking at. And then this for loop updates the electric field acting on tape 2 as tape 1 moves closer to it. And again, this uses the distributed charge principles. These are the results of my computational model. As you can see, the force of gravity and the electric force are about the same, which in lab 1 this was not the case. They were unequal, which proves that this is a better model. And I found Q to be this value, like I said, in slide 1, which is much closer to the true value than in lab 1. So moving from this, the assumptions of the lab were that charge is perfectly evenly distributed. Both tapes have the same amount of total charge. And again, one tape was a point charge, and I ignored air resistance. This brings up further discussions, such as what if I modeled each tape like a single point charge? Well, we saw this last week, where the total charge was a much different value, and it led to incorrect data and assumptions. And then in this lab, I found a much closer value to the real value. And then these differ because the distributed charge model more accurately reflects what's going on. And one point charge results in an electric field coming from one location as opposed to multiple different spread out locations.